Good evening, everyone. So this week we'll continue our lecture series on dermatopathology, and we have already discussed the normal histology of epidermis and the normal histology of dermis, along with the various dermal structures that we usually see in a biopsy. And this week we will continue our discussion, and we will discuss each tissue reaction patterns in a bit of detail so that when we are analyzing these slides or when we are looking at the biopsy report, we are able to make some sense of what is happening. Okay. For a dermatologist, every slide is a clinico-pathological correlation. You need to correlate the findings that you see with your eyes to the findings that we see under a microscope. And when you're able to bring both of these together, when you're able to bring the pathological features and the clinical features together, you're able to make a better diagnosis. Sometimes you may change your diagnosis depending on pathology findings, or sometimes you try to explain the pathology findings as per the clinical morphology. But most of the time, it's easier for a dermatologist to understand the slides, understand the pathology when they have a good understanding of the pathomechanism. And that is where the lichenoid tissue reaction pattern is very important. The reason that it is important is because lichenoid tissue reaction pattern is shared by various dermatoses. Okay, so if you understand what is happening in that particular dermatosis, you'll be easily able to make out why do we see a lichenoid tissue reaction pattern under a slide, and what are the other features that we see along with the reaction pattern, so that we make a comprehensive diagnosis. For the residents or for the residents who are doing graduation in dermatology, we will discuss the lichenoid tissue reaction pattern, the common features, and then we will discuss individual disorders so that we can focus more on the differentiating pathological features or the common pathological features of different disorders under a slide. Okay, so with that, without much further ado, let's start our discussion this week on lichenoid tissue reaction pattern. So these are the major reaction patterns. You have more or less 6 to 8 reaction patterns depending on the book or the source you are listening to. But let's divide them into predominantly epidermal and predominantly dermal. Okay. So reaction patterns like psoriasiform, spongiotic, vesiculobulous, these are predominantly epidermal. That means the majority of the findings are there in the epidermis, while the reaction patterns like lichenoid, granulomatous, leprosy, vasculopathic, and sclerosing reaction patterns are predominantly dermal. That means majority of the findings are there in the dermis, with few ancillary findings in the epidermis. Now, a slide may have more than one reaction pattern. Okay, you can have a lichenoid reaction pattern or a granulomatous reaction pattern along with a psoriasiform reaction pattern in the epidermis. So, one reaction pattern does not necessarily point towards a clinical diagnosis. You have to take all the findings together. So, like in previous videos, we discussed how to identify normal structures in the epidermis and dermis. With the discussion on reaction patterns, we'll discuss how to identify those reaction patterns. And the end point, the end histological diagnosis is made by taking all the findings together that we see. And this week, we'll discuss lichenoid tissue reaction pattern. So as of in various sources, 6 major reaction patterns are mentioned. You have the psoriasiform, spongiotic, vesicobulous, lichenoid, granulomatous, and vasculopathic. The additional patterns like leprosy patterns or the sclerosing reaction pattern is seen in is mentioned minorly. I don't think so. Minorly is a word. It's mentioned in few of the literature reports. Okay. So I will focus today on lichenoid tissue reaction pattern, which consists of basal cell damage as the pathological feature. And we will discuss in detail the interface dermatitis part. Let's move forward and start our discussion on lichenoid tissue reaction pattern. Now, lichenoid reaction pattern is also known as interface dermatitis. Okay, interface dermatitis, but it's a very important point to understand. Interface dermatitis is not same as lichenoid reaction pattern. There are subtle differences between these two. Lichenoid reaction pattern is a bit different from interface dermatitis, and as we progress through the lecture, we will come to know what is the essential difference between these two, but more or less there is a common finding of keratinocyte damage. There is damage to the keratinocytes with or without basal vacuolar change. Now, basal vacuolar change is a very important and essential feature of a lichen or tissue reaction pattern. And we see that in various disorders, this basal vacuolar change can be different. Some may have light change, some may have a major vacuolar damage. Okay. Just remember that interface dermatitis or lichen reaction pattern means that the inflammatory cells extend to the epidermis. That means, see, all the inflammatory cells are going to come from the blood vessels, and the blood vessels lie in the dermis. If they have to come out of the vessel and destroy the epidermis or the keratinocytes at the epidermal level, the cells need to reach the epidermis. And when they reach the epidermis, causing destruction of the basal layer, you get what is known as interface dermatitis or lichen tissue reaction pattern. Okay. A characteristic finding in lichen tissue reaction pattern is the civet bodies. These are shrunken eosinophilic cells, that means they appear red or pinkish on an H&E with pycnotic nuclear remnants at the basal layer. So these are shrunken pinkish cell at the level of basal layer or below the basal layer, and that these colloid bodies or civet bodies symbolize destroyed keratinocytes. So when keratinocyte is destroyed, they become eosinophilic and they drop down at the level of papillary dermis or just below the basal layer, and then they are known as civet bodies, and it is very essential to identify these civet bodies. So as we said that there is basal damage, there is vacuolar change. So what essentially happens is, let's say that these are the basal layers which are arranged in a line at the level of basal layer, or at the level of the basal epidermis, the stratum basale. Okay, so this is just a line of basal cells. If they get destroyed, okay, so this is a cell which is destroyed at some level, and then there we have another basal cell which is destroyed, and the two cells in between are now dead. Okay, so they have undergone apoptosis, and after apoptosis, they will form colloid bodies. So these are shrunken eosinophilic remnants. And when these cells drop down in the papillary dermis, there will be a huge empty space here. Okay, there will be an empty space here. And this empty space is nothing but the basal layer vacuolization. So this is what we mean by basal layer vacuolization or the vacuolar change. Now, inflammatory infiltrate can either touch the epidermis, that means it is situated at the level of dermoepidermal junction. So it can be here. And this is seen in Lichen Planus and its variants, Lichen Sclerosis and the actinic porokeratosis disseminated superficial variant. Or it can obscure the dermoepidermal junction. That means it can extend and involve the entire junction of the basal layer and the dermis. Okay. And this is seen in Erythema Multiforme, paraneoplastic pemphigus, pleva, acute GBHT, drug reactions, fixed drug eruptions, wherever there is a profound keratinocyte damage. Okay. Now, alternatively or simultaneously, as the infiltrate is extending upwards and involving the basal layer or obscuring the dermoepidermal junction, the infiltrate can also extend downwards into the mid and deep dermis. And if the deep dermis is involved, we see that in disorders like lupus erythematosus, photolichenoid eruptions, and some drug reactions with deeper involvement. Okay. So remember that in lichenoid reaction pattern, there is accumulation of infiltrate at the level of the epidermis and dermis junction. It may touch the junction or it may obscure the junction. Okay. If it touches, it's the true lichenoid reaction pattern. If it obscures, then we call it as interface dermatitis. So now you can understand why these two terms are used interchangeably, because they mean essentially the same thing. Okay. But it just depends whether the infiltrate is just at the junction or obscuring the junction. But as we will go through with while discussing the different disorders, you will realize that there's not much difference whether it touches or whether it crosses. And that is why these two terms are used interchangeably, but there is a slight difference between them. Okay. Let's move forward. There is marked pigment incontinence. Now, where does the pigment come from? When you have keratinocyte damage, every keratinocyte has melanin. Okay, the melanin will drop down, and when it drops down, it gets accumulated or deposited at the level of papillary dermis. Okay, so good amount of pigmentary incontinence is seen in drug reactions, poikilodermas in which that pigmentation is a part, and lichenoid reaction in dark skinned people, because in dark skinned people you have more melanin. Okay, you have more accumulation of pigment at the level of epidermis, so more pigment gets lost. There's another entity known as satellite cell necrosis. In satellite cell necrosis, you will see a necrotic keratinocyte, and that necrotic keratinocyte will have lymphocytes surrounding it. So you will have lymphocytes either surrounding it or nearby. So these are lymphocytes, and that is known as satellite cell necrosis. So what actually is happening? The the lymphocyte which is there just besides the necrotic keratinocyte actually led to the death or the apoptosis of keratinocyte. Okay, so lymphocytes are actually damaging the keratinocyte, and that is why when these two cell bodies are seen together, that is known as satellite cell necrosis or lymphocyte associated apoptosis. In this, you see lymphocytes along with civet bodies. This is majorly seen in, it can be seen in all forms of tissue reaction pattern, but it is majorly seen in GVHD, regressing warts, radiation dermatitis, erythema multiforme, some drug reactions. Basically, where the inflammation is so profound that the lymphocyte is destroying and is found near about the colloid bodies or the civet bodies. So let us understand what exactly is lichenoid tissue reaction pattern. Okay, so we have the epidermis, we have the dermis, and this is the basal layer. Okay, stratum basale. So we can see the basal keratinocytes arranged in a line at the basal layer. Here we see the papillary dermal capillaries. Okay, papillary dermal capillaries. Here we have venules, and these are the dermal vessels, or dermal arteries or arterioles. Okay, so we know that there is a superficial vascular plexus, there is a deep vascular plexus, but they are both arterioles. Okay, so this is the rough schematic diagram of a skin biopsy. In lichenoid tissue reaction pattern, the characteristic feature is the presence of an inflammatory infiltrate composed of lymphocytes. So here you can see that there is a band formation. The inflammatory infiltrate is like a band at the junction of the papillary dermis and the epidermis. Okay, it looks like a band, like a strata, like a layer of inflammatory infiltrate at the junction of epidermis and dermis. And this inflammatory infiltrate leads to damages of the basal keratinocyte, leading to vacuolization. So this white cloud-like figure that you can see are destroyed basal cell, leaving behind empty spaces, which is known as vacuolization. And what happens to the cells which are destroyed? Okay, they are going to drop down and form civet bodies or colloid bodies. So here we have civet bodies. Okay, and these are nothing but shrunken eosinophilic apoptotic keratinocytes or destroyed keratinocytes. Okay. And if the cell has significant melanin, you have melanin incontinence. So this kind of darkish brownish or darkish blackish pigmentation deposition is the pigmentary incontinence. Okay, so this is essentially the basic findings in lichenoid drug reaction pattern. And this pattern, along with the various changes in the presentation of this reaction pattern and additional features, help you to guide the clinician to form a certain diagnosis. And we will discuss each and every feature quickly as we move through. Some of the infiltrate can be present at perivascular location. And if you have any glands in the epidermis, let's say eccrine glands or something, let's say this is an eccrine gland, you can have infiltrate surrounding the eccrine gland too. And this feature is mostly seen in drug reactions. Remember, remember, sweat is a mode of excretion. It's how the body get rid of chemicals. And drugs being chemicals, the endocrine gland secretes those chemicals out, water soluble chemicals out, and that is why the inflammatory infiltrate is around the glands. The inflammation is also happening around the glands. Let's move forward. So look at this picture, and you can actually understand, you can actually see for yourself that this is the band that is formed. Okay, look how it is like a band. It's like a layer extending from here to here at the junction of epidermis and dermis. Okay, I would highly suggest you to go to this URL. I'll put this URL in the description, and this leads you to a site where you can actually zoom in and see all the features of the infiltrate. But I just wanted to use a zoomed out picture so that I can show you that how in a lichenoid tissue reaction pattern you see a band of inflammatory infiltrate at the junction, and this is how a prototypic lichenoid reaction pattern looks like under a microscope. If we zoom a bit and see the individual cells, we can make out that the infiltrate is at the hair level. Okay, let me just change the ink color. So you can see that the infiltrate is at the junction of dermis and the epidermis, and at some places like for hair, okay, hair, these are all basal cells which are undergoing vacuolization or destruction. Okay. In fact, at this low magnification, you can still appreciate some colloid bodies, eosinophilic remnants. Okay. In fact, here also there's a colloid bodies. However, I'm not sure. This could be an eosinophil also, but looks much larger than a eosinophil. So here, because the cells are getting destroyed, it is leading to formation of civet bodies. Okay. Let's zoom out again. So this is a table that I have taken from Weedon Skin Pathology 5th edition. It's there on the page 18, and it highlights different dermatoses that show a lichenoid reaction pattern on a biopsy. So lichenoid reaction pattern, and in fact, Weedon's has also used the term interface dermatitis interchangeably, but Weedon's also tells you that there is a subtle difference, and all the difference have been highlighted in the video. So let's start with Lichen Planus variants like Lichen Nitidus, Lichen Striatus, Lichen Planus like keratosis, Lichen drug reaction. So if you group them together in Lichen Planus and its variants and lichenoid disorders, you will easily able to remember that lichenoid reaction pattern and the lichen diseases in which it is seen. So here I've easily given you 6 examples. It is also seen in fixed drug eruptions and erythema multiforme and variants. Other disorders like lupus erythematosus and dermatomyositis also show interface dermatitis, but here the infiltrate extends deeper into the deep dermis. Disorders like lichen sclerosis and atropicus has additional features of sclerosis and the epidermal atrophy. We have congenital disorders like disc-keratosis congenita and poikiloderma of civet or pityriasis lichenoides like pleve or PLC, which also shows interface dermatitis. Just remember, wherever you have poikiloderma, you will have features of interface dermatitis. Paraneoplastic pemphigus. Remember, paraneoplastic pemphigus shows different histological features. If you go through the modified Anhalt criteria, you will find that one of the criteria of Anhalt is that there is an interface dermatitis and in a biopsy. Drug eruptions we have already covered. Mycosis fungoides. Remember what is the pathology of mycosis fungoides? That the atypical lymphocytes arrange themselves at the level of dermoepidermal junction. And here the sign is known as either soldier sign because they look like soldiers who are at the border, okay, or it is also known as eyeliner sign. Maybe we'll discuss this the signs when we are discussing mycosis fungoides in the future. It's a very important topic for residents, and it's a very difficult topic to understand mycosis fungoides and CTCL. Even I'm afraid of reading CTCL nearly once a year. I read about it and I forget. So maybe we'll make a video so that the notes are forever in the uh, at internet. Okay, on internet. Let's move forward. Let's start with the prototypic disorder, lichen planus. which is the prototype disorder for lichenar tissue reaction. In lichen planus, you see band-like inflammatory infiltrate with very prominent civet bodies, which is part of lichenar tissue reaction pattern. Okay. Additional features are wedge-shaped hypergranulosis. Now, this wedge-shaped hypergranulosis is what we see as Wickham stria clinically. So this is clinically seen, while wedge-shaped hypergranulosis is seen under a microscope. And this is a very good or very important Viva question. It has been asked countless times, in at least when I was resident. The retipex become pointed, and that is called as sawtooth appearance. So, for example, if you have a saw that we usually use in cutting or chopping wood, and you see that the edge has serrations, so the retipex look like this sawtooth appearance. So that is known as the sawtooth appearance. You have Kasperi Joseph spaces or the Max Joseph spaces, which are clefts seen at dermoepidermal junction. And that is because of vacuolar damage. So initially it was thought that it's more of an artifact in a biopsy, these Max Joseph spaces. But now we know that if you have a biopsy and you have the dermoepidermal junction and there is intense vacuolization, these large spaces are known as Kasperi Joseph spaces. It is just a place at which the keratinocytes are damaged and you see large spaces. So here is a slide which I've taken from Weedon's. It is the prototypic slide of Lichen Planus. You see, let me just change the color. Yeah. You see variable acanthosis. You can see how thick the epidermis is at various levels. So variable acanthosis. You see hyperkeratosis, which is orthokeratotic hyperkeratosis. You see the prototypic band-like lymphocytic infiltrate. Okay, you can appreciate how the band looks more bluish because it's majorly composed of lymphocytes, and you can also appreciate this kind of basal layer damage. Can you see this focal basal layer damage? This is known as focal basal layer vacuolization. Okay, and additional to that, you can see that the retipex are getting pointed and flattened. Can you see this pointed retipex here? And that is what we say as sawtoothing of retipex. So this is sawtoothing of retipex. There is some extension of the infiltrate at the perivenular level or the perivascular level, but that is mild. The major infiltrate lies at the junction. And that is why we call lichen planus as the prototypic dermatosis of lichenar tissue reaction pattern. Let's move forward. In Lichen Planopilaris, there is lichenar reaction at the basal layer of follicular epithelium. So if let's say this is the dermoepidermal junction and this is the follicle, okay, and you have a hair shaft here. Let's just denote it by this. The infiltrate is surrounding the follicles, okay, perifollicular infiltrate. This infiltrate is dense and is composed mainly of lymphocytes and few macrophages. And if this infiltrate is at the basal level of the follicle and the infiltrate has now damaged the follicle, it leads to scarring. Okay, there's significant scarring of follicle, and when the entire follicle is lost because of inflammatory damage, it leads to formation of a linear fibrotic tract. That means the entire follicle will be replaced by a sclerosed area, and this is known as a linear fibrotic tract. And that makes Lichen Planopilaris a prototype of lymphocytic cicatricial alopecia. Alopecia means loss of hair, cicatricial means scarring, and because scarring is by lymphocytes, you have lymphocytic scarring alopecia. Okay. In late stage, when the destroyed follicles release its destroyed products, you may have granuloma formation. Okay, and that is because of follicular destruction. So some amount of granuloma can be seen. It has been reported, albeit rarely, but it has been reported. Okay, so look at this beautiful slide that I've taken from Pathology Outlines. Okay, and let me just change the color. Yeah, so this is the hair follicle. Let me mark it out for you. This is the hair follicle, and you can appreciate a bluish infiltrate surrounding the hair follicle. Okay, so this is perifollicular lymphocytic infiltrate, and on a horizontal section, this is the hair follicle. This is the hair follicle, and you have the perifollicular lymphocytic infiltrate. Okay, in fact, if you look closely, you will see basal damage here. And this is what the pathology is in Lichen Planopilaris. You can easily see basal damage here. There is multifocal basal vacuolization. In Lichen Nitidus, you have well circumscribed infiltrate. So what essentially happens is you have a biopsy, you have the dermoepidermal junction, and in Lichen Nitidus, the infiltrate is very well circumscribed. Okay, it involves 2 to 3 adjacent dermal papilla. So this part of dermis which goes inside the epidermis is known as dermal papilla. So the infiltrate will involve about 2 to 3 dermal papilla. And wherever the infiltrate is present, it will lead to flattening of the epidermis. Okay, the epidermis would be flattened. So here you can see the epidermis is flattened. Okay, and whenever there's flattening of epidermis in Lichen nitidus, it will look like a claw which is clutching a ball. So the infiltrate is the ball, the retipex are the claw, and that is why it is known as a claw clutching morphology or a claw-like morphology, and that is the histopathological feature in Lichen nitidus. The inflammatory cells push against the undersurface of the epidermis, which becomes atrophic with parakeratosis. You have scaling, and the civet bodies are occasional. So look at this slide from pathology outlines, and you can see that the dermoepidermal junction, you have circumscribed localization of the inflammatory infiltrate, and it is composed mainly of lymphocytes. In fact, here also you can see lymphocytic infiltrate. Okay, there is focal basal cell damage. So here the basal cell damage is there, and you can see a bit of colloid bodies at the junction, and you can see that there is a claw-like extension. If I change the color, yeah, a claw-like extension. This is a claw, this is another claw, which is clutching the ball of infiltrate, and that is what is known as the claw-like morphology in Lichen nitidus, or claw-like histology in Lichen nitidus. Again, a Lichen nitidus showing epidermal atrophy, and you can easily appreciate how it is spanning 2 to 3 dermal papilla and also the claw-like extension. Let me change to this. Claw-like extension here, claw-like extension here, and you have the well circumscribed infiltrate. Let's move forward. In Lichen striatus, you have lymphocytes, histiocytes, and melanophages. Okay, melanophages, which encompasses 3-4 dermal papilla. The epidermis is acanthotic with mild spongiosis. The spongiosis has exocytosis. Now, what is exocytosis? That means some lymphocytes are crossing the dermoepidermal junction and going inside the epidermis. Why that is happening? Because the basal layer is destroyed. It is not restricting the entry of lymphocytes, and that is why lymphocytes are going inside the epidermis. You have parakeratosis, which is clinically equivalent to scaling, and mild hyperkeratosis. You see dyskeratotic cells at all layers of the epidermis, not seen in Lichen planus. What do we mean by that? It's a very important point. Make sure it is clear. In Lichen planus, you have the dyskeratotic cells at the basal layer. Okay, but in Lichen striatus, this dyskeratotic cells are seen in all layers of the epidermis. Okay, in dermis, there will be papillary edema with a milder infiltrate with perivascular and eccrine extension. So in Lichen striatus, if you see and look at this zoomed out image, you can see this keratotic cell here, you can see this keratotic cell here, and this keratotic cell here. Now, what is essentially are dyskeratotic cells? Dyskeratotic cells are just keratinocytes who are not able to properly mature into normal keratinocytes. Okay, there is slight difference between dyskeratotic cell and an apoptotic keratinocyte. If the basal keratinocyte undergoes destruction and drops down, it becomes a colloid body. If any other layer gets destroyed, that means upper layers of the epidermis, the keratinocyte will form apoptotic or necrotic keratinocyte. And if the keratinocyte is destroyed because of inflammatory damage, it makes apoptotic keratinocyte. If the keratinocyte is destroyed because of altered or a wrong maturation, it forms dyskeratotic cells. This means not normal, and keratotic means keratinization. So dyskeratotic cells. Okay, you can see the infiltrate which is extending a bit deeper perivascular infiltrate, but the infiltrate is not dense, it is mild. Here, however, you see a much denser, deeper infiltrate, but there is an overlying band-like infiltrate which is prototypic of lichenoid tissue reaction pattern. So you understand why we see lichenoid tissue reaction pattern in Lichen Striatus as the name suggests. Let's move forward. In lichenoid drug reaction, you have focal parakeratosis, which is scaling, mild basal vacuolar change. Important point to understand is eosinophils. Okay, so what actually happens is you have a red eosinophil, a red cytoplasm eosinophil with a bilobed nucleus. If you need to understand in detail how to identify eosinophil, go watch the video on dermal structures and the histology of dermis, and you'll be easily able to find eosinophils in infiltrate. Okay, the infiltrate is less defined, but you have eosinophils and sometimes plasma cells also. The apoptotic keratinocytes are above the basal layer as opposed to LP. I told you that in Lichen Planus, the apoptotic keratinocyte is at the level of basal layer or below, while in the lichenoid drug eruption, you can see it in various layers. There is more melanin incontinence. So if you look at this histopathology slide, the band-like inflammatory infiltrate is present. Okay, this band-like infiltrate is present. You can see one necrotic keratinocyte at this level. Look at here. They are present at different levels in the epidermis. Okay, so apoptotic keratinocytes are at different levels, and I think this one is a eosinophil, while this one is more of a necrotic keratinocyte. Okay, and you can see focal basal cell damage here. Focal basal cell damage here. You can see the infiltrate is composed mainly of lymphocytes with occasional eosinophils. Look at this. This is a eosinophil. Let me just refresh that. Yeah, this is yeah. So look at this eosinophil, another eosinophil. You can easily identify them by their red cytoplasm, eosinophil. So can you see this eosinophil richer than the infiltrate that we have seen in previous slides? Okay, so eosinophils are present in the infiltrate, and you have necrotic keratinocyte at various layers. This also is a better picture. You can see this necrotic keratinocyte at various levels. This is at basal level. This is a bit above. Look at this focus. You have all the layers that have necrotic keratinocyte. You have associated parakeratosis. You have significant damage leading to good colloid deposition here. Okay. So these are all features of fixed drug or a drug like a drug reaction. You have sparse infiltrated in the upper dermis. Look at this focal basal vacuolization. Okay. In fact, if you look closely, in fact, I have to also look closely, you can find occasional eosinophils in the infiltrate, just above the areas which I have marked. Okay. Let's move on. In fixed drug eruptions, you have lichenoid reaction pattern with prominent vacuolar change and civet body formation. This is same as lichenoid reaction pattern. Apoptotic keratinocytes are at all levels. This is the same as lichenoid drug reaction. The inflammatory infiltrate obscures dermoepidermal junction, extends to mid and upper epidermis. There is numerous eosinophils. Okay, so you might have noticed that whenever we are talking about drug reactions, we do mention eosinophils, EOs. And whenever we are talking about mucosa, we also see plasma cells. Okay, so in fact, whenever you see in a biopsy of, let's say, oral lichen planus, you will see plasma cell rich infiltrate, or infiltrate will have sufficient amount of plasma cells. And if you see amalgam associated oral LP, you will see more of eosinophils. Okay. So eosinophils are predominantly seen. There are other clinical variants of fixed drug eruption like bullous, eczematous, vasculitic, non-pigmenting, and you see additional features. For example, in bullous, you will see a split in the epidermis, dermoepidermal junction. In eczematous, you will see significant spongiosis. In vasculitic, you will see significant destruction of blood vessels. So destruction of blood vessels. Okay, in non-pigmenting, the pigmentary incontinence will be less. We all know that clinically FD is present as a hyperpigmented macule, which may or may not have a surrounding inflammatory erythematous perilesional erythema. Okay, in the non-pigmenting one, you don't see that much pigmentation, and the pigmentary incontinence is less in in histology. Now, just another feature that I should say is whenever you want to biopsy a fixed drug eruption, biopsy an active lesion. Okay, biopsy an active lesion because all you're going to see is pigmentary incontinence if you biopsy an older lesion. If you really want to appreciate eosinophils, biopsy an active lesion and try to get a biopsy from the inflammatory edge so that you are better able to appreciate the infiltrate. Okay, if you take biopsy from the center, you will just see majorly pigmentary incontinence. If you take a biopsy from the inflammatory edge of the lesion, let me just make a small diagram for you to understand. This is the fixed drug eruption, which is a bit darker, and many a times it has ill-defined erythema surrounding it. So take a biopsy from the junction, so you are better able to appreciate the infiltrate. Okay, if it shows eosinophils, it goes more towards fixed drug eruption. So this is a biopsy of fixed drug eruption. You can see intense damage at dermoepidermal junction. As I've said, it obscures or it covers the dermoepidermal junction. You see significant vacuolization. You see good amount of necrosis happening. Let me mark it clearly. Look at this level of necrosis. Okay, very dense basal cell vacuolization. That is all because of inflammatory damage. And the deeper sections are not shown, but they would have shown a good amount of pigmentary incontinence. Erythema multiforme. Erythema multiforme has, just a second, yeah, mild to moderate lichenoid reaction pattern that obscures dermoepidermal junction. If you recall what we have discussed between interface dermatitis and lichenoid tissue reaction pattern, you will understand that when it obscures dermoepidermal junction, it is better to call it as interface dermatitis. And that is what we see in erythema multiforme or SGS-TEN, TEN, GVHD or drug reactions. Okay, there is prominent epidermal cell death at multiple levels. That is how there can be prominent epidermal necrosis in a biopsy. There is some epidermal spongiosis and there is eccrine gland involvement. Okay, dermis has pronounced dermal papillary edema. That means significant dermal papillary edema. The infiltrate is composed mainly of lymphocytes and macrophages and also around the superficial and deep dermal vessels. Sorry, superficial and mid-dermal vessels. So if we make a small schematic diagram, dermoepidermal junction, the infiltrate is present at the junction. Okay, it obscures the dermoepidermal junction and it is also involving the mid and superficial perivascular location. Okay. Initially, there was a differentiation between epidermal, dermal, and mixed the level of infiltrate in various types of erythema multiforme, but now this differentiation is not used. So look at this. Can you easily appreciate the perivascular location? Okay. See here, around the vessel. See here, around the vessel. Okay, around the vessel. So you can see that there is extension of infiltrate downwards, majorly around the vessels, but you have significant basal cell damage. Basal cell damage. Okay, in erythema multiforme, but there is no separation of epidermis. The epidermis has focal basal cell damage, but there's no separation. We'll see separation in the next slide. Toxic epidermal necrolysis. The toxic epidermal necrolysis, the infiltrate is more confluent. It is more covering the dermoepidermal junction. There is significant epidermal necrosis leading to formation of a subepidermal bulla. That means there is a split between the epidermis and the dermis. The infiltrate can be sparse, and there is satellite cell necrosis. Why? Because in early lesions, lymphocytes are destroying the keratinocytes. Okay, so there is satellite cell necrosis, but the distinctive feature is subepidermal bulla with overlying epidermal necrosis. So look at this slide now. This is toxic epidermal necrolysis. As the name suggests, there has to be necrolysis. There has to be a split. So this is the split. Okay, and this is the somewhat a sparse infiltrate. Sparse infiltrate. Okay, but the essential feature is the split that you see here because of confluent necrosis. In fact, you can easily appreciate the focus of necrosis which is happening in the epidermis at various levels. You can see that the cells are getting vacuolization. There is white or empty spaces appearing. These are all necrosis which is happening, confluent necrosis involving the entire epidermis. Now let's discuss Discoid lupus erythematosus or DLE. You have the lichenoid reaction pattern with superficial and deep dermal infiltrate of inflammatory cells. Now what do we mean by that? That means if this is the biopsy, the infiltrate is at the dermoepidermal junction along with deep dermal involvement. Okay, and this dermal involvement is around the vessels. Here is a vessel, here is a vessel, okay, around the vessels. So whenever you see a lichenoid tissue reaction pattern at top and dense perivascular significant infiltration of the deeper vessels, deeper dermal vessels, along with good amount of arterial destruction, think of DL. Okay. So there is a lot more cell death as compared to vascular change. You will see intense necrosis in autoimmune disorder like DLE. If the biopsy is from a scalp, which is the more common area involved with DLE, and it has scarring alopecia, the fibrosis of the follicle is seen. You have decreased sebaceous gland, and there is infiltrate around the sebaceous gland also. So what essentially is happening is that the infiltrate is so much that it is destroying the follicle, leading to scarring alopecia, and that makes discoid lupus erythematosus another example of lymphocytic cicatricial alopecia. Okay, so we are kind of learning and correlating lymphocytic cicatricial alopecia, which is a type of cicatricial alopecia on histology. There are other types like neutrophilic rich mixed cell infiltrate, but it's an interesting prospect to read. Let's come back to DNA. Nuclear dusting is seen in early stages. This is nothing but remnants of neutrophils. Okay, basement membrane thickening in later stages. In later stages, the basement membrane is thickened and you use periodic acid shift pass. The pass is essentially used to stain the basement membrane and you can easily appreciate the thickened basement membrane and that is known as pass positive basement membrane thickening. So this is DLE. You have the involvement in the upper layers of the epidermis. Let me just switch the pen color. So, okay, the upper dermis is involved, and if we move forward, we can you see this deep dermal involvement, deep dermal perivascular involvement? Okay, look at this dense infiltrate, dense lymphocytic infiltrate. But you can appreciate that the basal layer vacuolization is not that much present. This is dense dermal superficial perivascular infiltrate. This is deep perivascular, this is superficial perivascular, but the infiltrate at the level of dermoepidermal junction is not that pronounced. It is still present. Look at this. It is still present. Okay. In fact, in this low magnification, you can appreciate the basement membrane thickening. Okay. So look when I remove this mark. Can you appreciate this thickening? Now the stain which is side is Alcian blue. And what Alcian blue does is it stains mucin. So you can easily appreciate that mucin is increased in prolonged sun exposed areas in DLE, leading to significant solar damage. And if this would have been HNE, all the blue areas would have been white, and you would have just seen empty spaces in between, and you would have made a diagnosis of dermal edema. But if you have a strong suspicion of Discoid lupus erythematosus, then you use special stain like Alcian blue to stain for mucin and see this amount of mucin in the slide. In subacute lupus erythematosus, okay, you see the infiltrate is quasi-inflammatory. That means the density of infiltrate is low. It is decreased. You have vacuolar and lymphocytic interface dermatitis because that's what we are studying right now. You have more basal vacuolar change, more vacuolization. In DLE, it was less vacuolization, more cell death. Okay. You have epidermal atrophy, dermal edema with superficial mucin. There is less hyperkeratosis, pilosebaceous atrophy, follicular plugging, basement membrane thickening, and cellular infiltrate. That means the destruction is somewhat lesser. There are more features with a more pronounced basal vacuolar change. You see apoptotic keratinocytes or civet bodies at all levels. Just remember that civet bodies is a term used when basal layer is affected, while apoptotic keratinocyte can be used for any cell destruction at any cell layer. So here, can you see the thickened basement membrane? This must be a lesion which is older now. You can see that there is pericapillary infiltrate. You can see that there is significant vacuolization. Okay, so can you appreciate how the thickening of basement membrane can be seen in HNE also? The infiltrate is a bit less, and but the vacuolization is much easily appreciated. So remember that when you're biopsying a lesion from SLE or SCLE or subacute or discoid lupus erythematosus, you have to look at all the features. It's not that you will see lichenoid tissue reaction pattern with a thickened basement membrane with some amount of focal basal cell vacuolization, and yes, it can be anything from DLE to SLE. No, look at everything. Look at mucin. Look at slight solar elastosis which is present here. But of course, you will be able to differentiate these features when you see a lot of different slides. So in this subacute lupus erythematosus, you can see parakeratosis. Look at this. This focus has a bit of parakeratosis. You can see granulosis. You can see the perivascular lymphocytic infiltrate here. You can see now that the vacuolization is very prominent. Look here, look at here, look at here. Okay, you can see that the basal cell vacuolization is now more prominent as compared to DLE. The mucin or empty spaces is milder as compared to DLE. Let's move forward. In this, you can easily see that vacuolization is again a predominant feature. Look at all these empty spaces. As compared to DLE, you see more of epidermal features with a sparse infiltrate, more of vacuolization. While in DLE, you see less vacuolization. In systemic lupus erythematosus, that means in skin lesion, in skin biopsies in SLE, you see prominent vacuolar change involving the basal layer. Civet body formation is not usually a feature. That doesn't mean you cannot see. You will see, but it is less than as compared to previous slides. There is milder lymphocytic infiltrate. There is fibrinoid material around vessels. That means there is more predominant vessel destruction. More predominant vessel destruction. Mucin is present. Okay, so if the infiltrate is extending to the deeper dermis with significant destruction of vessels, you consider systemic lupus erythematosus. You can easily see that a blood vessel will be, surrounded by what color can we use to show fibrin? Let's use this. So not visible. Yeah, so you can see there will be significant deposit of fibrinoid material or a light pinkish amorphous without any form material around the vessels. So the more slides you see, the easier it will be for you to appreciate that. So with that, this whole humongous lecture on lichen tissue reaction pattern is completed. Again, I would like to recommend these two books at the basal level. If you are not interested in dermatopathology and just want to read at the residency level, these two books are more than enough. If you really want to learn, or if you, like me, are interested in dermatopathology, graduate yourself to Weedons and Levers and Mckees and individual websites and articles. Okay. These are some reading recommendation. Weedon Skin Pathology. Weedon Skin Pathology, 5th edition is the latest one, I think. Fundamentals of Pathology, I've already mentioned. IADVL textbook with Dermatopathology. It's a very good book. Personal interest, I have a chapter in that, so bias are there. PathologyOutlines.com is a very good online resource. They have good quality histopathological slides, and you can actually see those features. Mckee's Dermatopathology is another good book. It is simpler to understand. It is easily given in notes format. And this is the URL that I was mentioning where you can see a Lichen Planus slide and you can zoom out. You can zoom out to such a significant level that you are easily able to appreciate the cellular contents in the infiltrate. So I would really recommend you to go to this URL, copy paste it. I'll put it in the description and look for yourself how to analyze the different areas of a slide. With that, I've finished this week's lecture on lichen tissue reaction pattern. Lichen tissue reaction pattern is one of the most important dermal reaction pattern. I think this and the mixed cell infiltrate or mixed cell granulomatous infiltrate, these are the two major reaction patterns that we as dermatologists should be aware of. Other patterns like leprosy pattern or vasculopathic pattern or sclerosing patterns are also important. And gradually we'll discuss. Maybe the video of subsequent reaction patterns might not be as long as this, but this is an important reaction pattern to understand. And in the future, if you're looking at the slides or reading the biopsy reports, you should know what exactly is happening. And I hope that now if you read a biopsy report that has a lichen tissue reaction pattern or interface dermatitis written, it forms a mental picture so that you are easily able to understand what exactly is happening. So I will not take much of your time. Adios. Bye bye. We'll meet again next week, and this time we'll discuss the granulomatous tissue reaction pattern. Bye.